Hello, so we talked earlier about finding the optimal solution for this scenario. So manufacturer selling to the customer, but then right now the production cost would be non-zero. So specifically, C equals to 0.1. So then to quickly run through how to do it. So then let me do it and illustrate. So first we have demand equals to 1 minus P. Okay. And then the profit equals to P minus 0.1, which is the production cost, and then multiplied by demand. So I do the shift enter. So right now, if we plot the demand, so we have exactly the same graph as before. But then if we plot the profit, it looks slightly different. So let me show it to you. So if we plot the profit, so it actually looks like that. So what does it mean? So then if I sell the product at price equals to 0, then I would be losing the production cost. So there's one customer, but I'm losing the production cost, which is 0.1. So therefore, when you look at this on the left-hand side, when the price is 0, then the profit equals to minus 0.1. And at least we have to sell the product at cost at the price equal to 0.1. And then when I sell the price equal to 0.1, then I make 0 profit. And when I sell the product at price equals to 1, then the profit is still equals to 0 because no one is buying the product. So the optimal solution is somewhere in the middle. And of course, it's no longer 0.5. To do this problem, we basically repeat the same exercise. So first, I take the derivative of profit with respect to P. So D square bracket profit P square bracket. And I have 1.1 minus 2P. And I'm solving this 1.1 minus 2P equals to 0P. So what this does is to find the slope of this curve when it equals to 0. And then if I do shift enter, it turns out that price equals to 0.55. So what it means is that if I charge the price equals to 0.55, so I assign the value 0.55 into Mathematica. So P colon equals to 0.55. Then I do shift enter. So right now the blue P becomes black P. And when I do that, I can find out the demand. So DD equals to 0.45. That means if I charge the price 0.55, the number of customers buying my product will be 0.45. And how much money do I make? That would be 0.2025. So the next step is for us to extend. Rather than the cost equals to 0.1, it can be anything, okay? The cost can be anything. So what we need to do right now is to erase the definition of P and also profit and demand. So to do it, I goes to evaluation inside Mathematica. Then there's a quit kernel. Inside the quit kernel, I click local. And then once I click quit, then all the blue one, all the black one now becomes blue. So for example, if I do P, shift enter right now, P doesn't mean anything. So earlier I defined P equals to 0.55, but then remember that somewhere here, I clear the kernel. So therefore, right now, P is not anything, okay? And then same DD. So demand is also undefined. Profit is also undefined. So that means we start from the beginning. So right now, let's start from scratch. So what I'm interested is to solve this problem. So the manufacturer having a price of C, which is just a variable. And my question is, how much should the price be? So in Mathematica, we do pretty much the same thing. So dd colon equals to 1 minus P, shift enter. Profit colon equals to open bracket P minus C multiplied by dd. Okay, note that this is a round bracket and then P minus C multiplied by dd. So if I do shift enter, so let me show you. If I type dd right now, I would have 1 minus P. If I type profit right now, I would have 1 minus P multiplied by minus C plus P. Okay, Mathematica usually arrange the variable in alphabetical order. So it's minus C plus P. So we cannot plot a graph. Okay, what does it mean by we cannot plot a graph? So if we do profit P01, if I do shift enter, it would have a blank. The reason if I have a blank, because Mathematica does not know what is the value of C. In the past, when C is equal to 0 or C is equal to 0.1, then that is possible to plot the graph. But then right now, we do it C as a value of C. So therefore, Mathematica does not know what is the value of C. So therefore, it is not reasonable to plot what is profit. But still, we can do the calculation. So then the first step is to take the derivative of profit with respect to P, which is what we have done before. If I do shift enter, I would have 1 plus C minus 2P. So that means if I take the profit, so then the graph of the profit would have the slope 1 plus C minus 2P. And I want to set this equals to 0. To do it, we use the command solve 1 plus C minus 2P equals 0, comma P. Then if I do it, I would do shift enter. And that gave me P equals to 1 plus C divided by 2. So then to find out what is the optimal profit, so I assign the value P with 1 plus C divided by 2. So I just highlight this, copy, and paste. So the blue P, if I do shift enter, becomes black P. So a black one means there's some value inside P. So that means if I do P, shift enter, I have 1 plus C divided by 2. And then if I have to find out what is profit, so profit, if I do shift enter, it would have a long expression looks like that. And then demand, if I do shift enter, so I would have an expression. So every time if you see P, it get replaced with the word C. So to do research, so we are interested to find out some managerial implication. And to find the managerial implication, then we can play around from parameter. So right now we have a parameter called C. So then I want to know what is the value of C impact to the optimal price and also to the optimal profit as well. So let me illustrate what I'm trying to say. So let's say I plot the value DD with respect to C. So in the past, we plot the value from P, but then right now we plot from C. So the reason is that around the last exercise, when price is a decision, then we plot D equals to 1 minus P. And now what we are plotting is the optimal price. So price no longer is just a value, but then it's the optimal value. And I want to plot the production cost with respect to the optimal demand. So let me try to explain this graph. So I'm plotting the demand as a function of cost, production cost. When the production cost equals to 0 on the left-hand side, then the optimal demand that we would have is 0.5, this number. So where is this number coming from? Let's scroll back to the first exercise. The first exercise, what we have is this one. So before cost equals to 0, okay, not 0.1, but 0 equal to 0. And then after we plot dP01, and then we have the optimal profit. And then what we find out is that the optimal price is 0.5, and then the optimal demand is 0.5. So that means when the production cost is 0, then we would set price equals to 0.5, which leads to the optimal demand equals to 0.5. So this is what this point means when cost equal to 0. So remember the x-axis is C. So when cost equal to 0, then the optimal demand equals to 0.5. And then we also have done another exercise where the cost equals to 0.1. When cost equal to 0.1, we find out that price equals to 0.55. And then the optimal demand equals to 0.45. So that is actually this point. So on the x-axis is the cost. And then when cost equal to 0.1, then the optimal demand would be 0.45 because the optimal price at that time is 0.55. So therefore the price, the optimal demand is 0.45. So like on the right hand side, okay, so that means when the production cost is 1. So in that case, the optimal price would also be 1. And then when the price is 1, the optimal demand would be 0. So this is how you try to understand this graph. So this graph is the optimal demand taking into the account that the firm would charge an optimal price. So if we try to understand this picture, what this picture tells me is that for an industry with a low production cost, then it would have a high demand. And then for an industry with a high production cost, then the optimal demand would decrease. So this is what this picture tried to tell us. And then let's try to plot the optimal profit with respect to C. So plot profit C01. So this is the optimal profit. So let me show you what this picture looks like. So what this picture tells me is that when the production cost increase from 0 to 1, then the optimal profit would decrease. So let me remind you what this picture is. So let's go to our first exercise. In our first exercise, production cost equals to 0. Then we find out that the optimal price is 0.5, and then the demand is 0.5, and the optimal profit is 0.25. So this corresponds to this number. Okay, this corresponds to this number. On the x-axis is C, and then on the y-axis, C equal to 0, then the optimal profit is 0.25. Same thing. Okay, So then when the production cost is 0.1, then what we have find out is the optimal price is 0.55, and then the demand is 0.45, and the profit is 0.2025, okay, 2025. So that actually correspond to this point. So when C equals to 0.1, then the y-axis is 0.2. So this is how we interpret this profit, optimal profit. And then if you want to zoom in to different part, so that is possible as well. So for example, I want to zoom in to the right-hand side. So then that means I plot the graph from C equal to 0.9 to C equals to 1, and then we have exactly the same shape as well. So what we have learned from here basically is that as the production cost increase, then the optimal demand would decrease, and also the optimal profit would decrease as well. So basically that would be a finding. So that is not a very interesting finding, but still this is a mathematical finding. So let me stop here so that you can get some time to digest and ask me questions so that I can try to answer it before I move on to the next exercise.